You've now had some time to work on solving the random story generation problem on your own, so we'll go over a sample solution. To begin, we'll finish filling out the body of Build Dictionary, for which we had started to write some comments last day. This is an accumulator problem, so we'll have a variable, context to next words, that will initially refer to an empty dictionary. And we'll accumulate all of the contexts from the given text along as keys, along with the lists of next possible words as their values. We have a file called training text, and our first job is to read in that file. So we're going to use the open file reference, training text, and call the read method to get a string containing the file contents. Next, we'll take that string and split it so that we have a list of the words in the file. The next job we have to do is add the contexts and next words to the dictionary. So for each of the contexts, we need to repeat the task of adding it to the dictionary. How many contexts do we have? Well, let's say we have a text of 5 words and a context length of 1. In that case, we'd have 4 contexts, one for the first, second, third, and fourth word. The fifth word won't be a context because nothing follows it. Now imagine that we had 5 words again, only this time the length of the context was 2. In this case, the first and second, second and third, third and fourth words would form contexts. So we'd have 3 contexts. In general, the formula for the number of contexts is the number of words in the text minus the context length. So we've got index I referring to our current position in the list, and now we want to get the next context from that list. It will start at index I and be context length long, so we can use a slice as follows. Beginning at index I and going up to index I plus context length. That gives us a list of words for the context. We talked about using a tuple as the key for the dictionary, since tuples are immutable and dictionary keys must be immutable. To make this context a tuple, we can call this tuple method on it. Let's give that a try in the shell. So if we have a list, let's say the dog, and we'd like to convert that list to a tuple, we can call this tuple method, and it produces a 2-item tuple with each of the items of the list. Next, we need to figure out what word follows the context. We took a slice to get the context from I to up to but not including I plus context length. So the next word is going to be whatever's in that words list at index I plus context length. Now we have the context and the next word, so it's time to add them to the dictionary. If this context is not already in the context to next words dictionary, we need to add it. So in this case, the key would be the context, and the value would initially be an empty list. Then, regardless of whether the context was there originally or not, we will add to this dictionary for the key context the new word. So this looks up the key of the dictionary and produces its value, which will be a list. We'll append to that list the next word. Once we finish this task outside of the loop, we can return the context to next words dictionary. Now let's run this and give it a try. I've got a file named poem.txt that contains a little poem, and we will open that file. That's our training text. The other argument that we need to pass to the dictionary is, that we need to pass to build dictionary is the context length. So if I call build dictionary with the poem and a context length of 2, it produces this dictionary. Once the dictionary is built, we still have to build the story itself. Like we did together, I have on my own outlined the steps for generate story. This is an accumulated problem. We're trying to build a story, so we initially have story refer to the empty string, and in the end, we'll return the completed story that will be num words long. We're going to begin by setting a current context variable to keep track of what the context currently is. Starting out, I'm going to initialize that to none. Basically, I want to initialize it to something that's not in the context to next words dictionary. We'll now work on the task of adding one word at a time to the story until it reaches the desired length. So what we'll do is have a for loop that loops num words times, and through each iteration of the for loop, one more word will get added to the story. One of the design decisions that we need to make is how the story should begin. Should it always start with the first word from the training text? Or perhaps we should choose a word at random. In order to have stories produced that have a bit more variation, I'm going to choose the first word at random. Here's the code that we'll use to do this. We set out initially with a context of none, and so that context will not occur in the dictionary. We're going to get a list by calling the keys method of all of the contexts from the context to next words dictionaries. Next, I'm going to use a module called random and a function in that module called choice that picks an item from the list at random. The item selected will be the current context. In order to use random, we need to import it. So we'll add an import statement to the top of our file. Let's take a look at how this works in the shell. If we import random, we can then call on random.choice to return at random some item in this list. And so on. Let's go back to our function definition. Our next job is to produce a word from the next possible words that follow this context. So our dictionary is context to next words. The context we're working with is referred to by the current context variable. And when we access the dictionary at that context, we get a list of next possible words. So to generate the next word, we can use random.choice again, passing in that list, and it will return one of the words from it. We'll add the word to the story. And when we add a word to the story, we need to put a space between it and the word that comes before it. Now we need to update the context. The first word of the current context should be removed, and the word that we chose to follow the context should be added. So we use this statement. We get the current context from index 1 onwards, and then we're going to, which is a tuple, and then we're going to concatenate to that a single item tuple containing the next word. As we continue this process of adding words to the story, the majority of the time, the current context will be in the dictionary. So we won't pick the context at random. We'll be using the one based on what had come before. Let's give this a try. In the shell, I have already initialized the dictionary, and now we're going to call on the function generate story. It takes the dictionary as its first argument, followed by the context length and the length of the story to write. So calling it a couple of different times, we get a couple of different stories. Notice that there's always a space at the beginning. This has to do with how we created the story. So we can go in and fix that. We added a space before the next word, but that meant that when the string was initially empty, we were adding a space. So to fix it, we can take a slice of the story, removing the character at position 0, the space, and just returning the rest of it. I'd like to revisit a design decision that we made. If the current context was not valid, then we chose a context at random. This took care of how to start the story, but it also took care of another situation. Imagine that the next word chosen is the very last word in the training text. When combined with the current context, if we get the last word or words in the training text, then that will not appear as a key in the dictionary. We didn't put that context in the dictionary because nothing follows it. In that case, where we've reached the end of the original training text, that context will not be in the dictionary and we'll end up picking another context at random. So this code actually takes care of two scenarios. You could have handled these in the same way, or perhaps you split it up into two different situations. This solution is one of several possibilities. We took a lot of time to carefully plan the data types and programming methods that we would use to solve this problem. All of that planning pays off in the long run and allowed us to write the code in a relatively quick and straightforward manner. We had already thought the problem-solving process through. This type of planning generally pays off in the long run and results in cleaner, easier to read code that's also easier to implement.